For the review, I wanted to go over these to help you understand what is happening, just reinforce the things that you've already been trying. For numbers 1 through 6, we're trying to distribute and then simplify. So for number 1, we've got the 9x that's outside the parentheses. I can distribute that in to both terms. 9x times 6x is 54x squared, because we are multiplying two x's together. And 9x times negative 2 gives me negative 18x. As a reminder, I cannot simplify these two terms because they have a different exponent value. So we would leave it as 54x squared minus 18x. For number 2, first we'll take the 5x and distribute it into both terms. So 5x times 3x is 15x squared, and 5x times positive 1 is positive 5x. Next, we're going to take the minus 7 and distribute it into both terms. So minus 21x and minus 7. And the tricky part here is making sure that we can combine our like terms. And we can combine 5x and minus 21x to get me 15x squared minus 16x plus 7. Those two middle terms can be combined. Next one, I'm going to leave the 3 out there for a little while, and you'll see why. So we'll take the x and distribute it in. So I'll take the 3 and give it a bigger shell on the inside. So x times negative 2x gives me negative 2x squared. X times positive 5 gives me positive 5x. Plus 6 will be distributed in as well, so minus 12x and plus 30. We want to combine our like terms. So I'll drop this down. Minus 2x squared plus 5x and minus 12x will give me minus 7x plus 30. Finally, we'll take this 3 and distribute it in to all terms, now that it's completely simplified inside those parentheses. So 3 times negative 2x squared gives me negative 6x squared minus 21x plus 90. Number 4, a little bit tricky because we've been multiplying, but then this time we have an addition sign in the middle. So we're going to essentially see if you can simplify inside the parentheses, which you cannot, and then we're just going to add or subtract. In this case, we're going to add. So we're going to add like terms that I've underlined here. So 4x minus 6x gives me negative 2x. And plus 2 minus 10 gives me minus 8. And you are done. For number 5, a little bit tricky because we have this minus here instead of the plus. So we're going to take and distribute that minus to each term inside. So we'd end up with negative 9x plus 2 minus 2x plus 6, because if you remember, a negative times a negative nets me a positive. We'll recognize that we have like terms, and I will need to combine them. And when I do combine them, negative 9x and negative 2x gives me negative 11x. And plus 2 plus 6 gives me plus 8. And there we go. Negative 11x plus 8. Going back to the multiplication, For number 6, we'll take the 5x and multiply it in. So distribute that 5x in, give me negative 15x squared minus 5x. And then plus 7 will get distributed in as well. So minus 21x minus 7. Combine those like terms. Should have negative 15x squared minus 26x minus 7. For number 7, we know that this is what our f of x is going to equal. When we have a value for that x, we simply plug it in. So for f of negative 3, we're going to plug negative 3 in for x every time we see it. So negative 3 minus 2 plus 4. Negative 3 minus 2 is negative 5. Plus 4 is negative 1. So f of negative 3 would equal negative 1. I need to do the same thing when we're trying to find, when x is 0, trying to find the output of f of x. So f of 0 equals 0 minus 2 plus 4, which would equal negative 2 plus 4. Therefore, f of 0 equals a positive 2. For number 8, same process, a little bit different result, but we're going to take that negative 2 and plug it in everywhere we see an x in here and then solve. So f of negative 2 equals 2 times negative 2 plus 4 and negative 2 minus 6. So 2 times negative 2 gives me negative 4. Negative 2 times negative 2 minus 6 gives me negative 8. Negative 4 plus 4 gives me 0 times negative 8, which gives me 0. So f of negative 2 is equal to 0. When x is equal to 4, we need to try to find f of 4. So, same process. 2 times 4 plus 4, 4 minus 6. So 8 plus 4, and 4 minus 6 is negative 2. F of 4 would end up being negative 24. Number 9. When x is negative 1, find out what f of x is. So negative 1 negative 1 minus 1 is negative 2. So f of negative 1 is 2. And f of 5. Minus 1 squared minus 2. So 4 squared minus 2. 16 minus 2. F of 5 equals 14. Number 10 is the tricky one. Admittedly, f of negative 2 equals 2 to the negative 2 plus 2 power minus 3. Well, negative 2 plus 2 is actually 0, so 2 to the 0 minus 3. And as we've already talked about a number of times, any non-zero number to the 0 power gets me 1. So f of negative 2 is actually negative 2. So trying to find f of 3, 2 to the 3 plus 2 minus 3. 3 plus 2 is 5. 2 to the 5th power is 32. Minus 3 tells me that f of 3 equals 29. What kind of function is this? Something that we've been talking about quite a bit throughout this module. And we know that when we are taking 2 times, we are going to be doing something specific. So because I've defined the first term and I'm going off of what's happening every previous term, we know that all of these are going to be recursive functions. Then it's a matter of, is it linear, quadratic, exponential, neither, arithmetic, or geometric? And because we're multiplying by 2 in this case, we know that it is a geometric and exponential. The next 3 numbers in the sequence, we've defined f of 1. So we know the first term. We know that f of 2, f of 3, and f of 4 is what we're looking for. We need the next 3 terms in the sequence. So with this, we have 2 times the previous term. Well, the first term was 5, so 2 times that is 10. 2 times that is 20. 2 times that is 40. There you go. For number 12, again, we know that this is a recursive equation because we've got f of 1 defined, and we know we're going off of the previous term. So we know that this is arithmetic because we are subtracting 2 every time. And because of that, we also know that it will be a linear function. So we know f of 1, we need to find f of 2, f of 3, and f of 4, a function of each of these values. So starting at 5, we subtract 2, get 3, get 1, get negative 1. For number 13, again, we know it's recursive, but this time we're adding an x. And if you recall from the review sheet that we have, when you have that x added out there, it is considered a quadratic function. Okay. So because of that, f of 1 equals 5. We need to find f of 2, f of 3, and f of 4. And so what this is telling us is that we are going to take our previous term and then add our previous output and then add our input. So our previous output was 5, and we need to take 5 plus 2, which gives me 7. 7 plus 3 gives me 10. 10 plus 4 gives me 14. So you take your previous output and add your input. Number 14, make a table of values for the graph. Okay, I can do that. So we have our t, and our f of t. T is representing time. Function of time is going to actually be our height. So the time can be 0, 1, 2, possibly 3 seconds. And at 0 seconds, we can say that it looks pretty close to 80 meters off the ground. 1 second, table says it's 128 meters off the ground. 2 seconds, 144 meters off the ground. So describe the first and second differences. Well, the first and second differences can be found here. Difference of 48 and then 36, not 36, 16. So then 48, so the first common difference is not common at all, which tells me that I need to go to a second difference. So 48 minus 16 will get me a negative, how do I get down? I'm going to need to subtract 32. So our first difference is here. Our second difference will be here. If I were to continue this on, if I knew more information at 4 and 5 seconds, I knew what happens at 5, and we'll get there shortly. But what kind of function is this? Based on what you see here, based on the fact we know that we don't have a common first difference, I can say that this is going to be a quadratic function. Then, from the graph, we need to find f of 0. So we're trying to find at 0 seconds how high off the ground is this object. So when the time is 0, we know that we are 80 meters off the ground. At 2 seconds, we know that we are 144 meters off the ground. At 4 seconds, let me clean this up a little bit. At 4 seconds, we are 80 meters off the ground. And if you notice, we have something that we're going to talk about in the next module where it's actually called an axis of symmetry, so that on this side it mirrors that side. We'll get there very soon, trust me. But for right now, f of 4 is going to equal 80 meters. And finally, f of 5 represents the object hitting the ground. Hopefully this helps. Please feel free to reach out with any questions you may have.